first of all, let's overlook the program. I'm Mark Blij, I'm CPO, I'm product specialist at Orfit Industries. And this afternoon, as I mentioned, we will discuss our check materials, especially the check socket materials. We will go through our PETG, which is not that long on the market. We will discuss our Orfitrans stiff products. And most important for you, I think, is the product similarities. Also, we will discuss some differences. And I will point out some attention points when you're fabricating and using our materials. Of course, you will be able to ask some questions at the end of the presentation, although you can already put some questions on the chat, and I will try to answer them as good as I can. And I will have to point to my, okay, so my pointer was not working immediately, it's working right now. We have our Orfitrans range. The Orfitrans range, I try to divide it in big three parts. From top, you will see the check socket materials, generally speaking, the check materials, which you can use for check sockets. And we have two products in there, which we will discuss today, PETG and Orfitrans stiff. For next Thursday, we will have another webinar, where we will discuss the inner socket materials, and they are listed from the most rigid inner socket materials to the most soft ones, which is the Supra soft. On the right-hand side, you see the orthotic materials. Some of our materials can be used for test orthosis and also for definitive orthosis. So that's what we're going to do today. What are the necessities of check materials? Well, check materials, when you're making a device for your patient, you will need some material that you will be able to see through, where you can see what's happening inside. You need a strong material. In the case of prostheses, it should be able to carry the weight of a patient. If you are making test orthosis, in the case that you will have to realize a device that is difficult to adapt, when you are, for instance, using carbon fiber, you will be able to produce a test orthosis with our materials. So that's the reason why I divided in three different groups, and we will go to the next slide, which will point out our Orfitrans PETG. Our PETG has been on the market not for that long time. And the reason for that is that we have been developing a product that has some more qualities compared to the products which are on the market right now. We will use it for the short time test for sockets and orthosis, and we recommend to do that in a supervised environment. It is our most rigid product, although it's easy to modify. If you can heat it, you can modify it quite easily. And the big advantage of our PETG versus the competition is that it's much, much stronger. It's nearly indestructible. It has also a very high impact resistance. We use a PETG as base for it, and the advantage of the PETG that we produce is that it's very clear and transparent. So you can really see easily through it when you're making your test device. As you see, there is a link to YouTube. Be aware that we will send you the presentation later or after this afternoon, so that you can have a link to the YouTube where we demonstrate the impact resistance by a drop test that we performed in-house. And we've been dropping several sockets from a height of 8 meters. You will be able to see what's happening. What I forgot to mention is that on the private side of this presentation, that we are recording, so that you are aware that we are recording this presentation, just for your knowledge. Okay, that's about the PETG. On the other hand, we have the Orfitrans stiff, which is our second but oldest test material. We use it for longer trials, for sockets and orthosis. It has been on the market for several years. It has proved its quality. That's the reason why we call it the gold standard for test sockets and also for orthosis. It's one of our most rigid products. It's a little bit less than the PETG, although it's absolutely indestructible, so you don't have to worry about that. It has a very high property of a minimal shrinkage, which is about 0.8%. The impact resistance is also very high, and that comes because it's styrene based. The color is also transparent, although it has a blue shine, so you can find or make the difference between our stiff and our PETG just by looking at the color, and you will recognize the bluish color for the Orfitrans stiff. And we also offer this in thicknesses from 8, 10, 12, and 15 millimeters. What's the another advantage of stiff compared to the PETG? That it's a bit less in weight. We have a density of 1.01 gram per cube centimeter, which makes it a bit lighter than PETG, which is also a reason to have a longer testing area, and you can let your patient use it quite more easily. In the third, but you can't see the difference, we have in our range, we have the stiff Protect. Protect is new in our range. You will see that also in the next webinar on Thursday, that we have a new name and it's called Protect. Protect is a product that we add, and it acts as an antibacterial device. Be aware that the antibacterial product is mixed completely in our product in the stiff. So if you sand it down, if you grind on it, everywhere you have been touching it, it will remain antibacterial. So you don't have to worry to sand down a little bit here or there. It acts against the MRSA. It acts against the Staphylococcus aureus. It also prevents the Supra bacteria to grow, and also the VRE. The result of this is that it really controls the odor and also the bacterial growth inside your socket. So Protect, generally speaking, is an antibacterial protective element that we mix in our raw material before we extrude the sheets for producing. What will be a criteria to use stiff versus Orfitrans stiff Protect? On one hand, you will use Protect in any case where you have a patient, where the patient is in direct contact with the skin to the socket. That's one of the reasons why you will use the Protect. On the other hand, if you have a patient who sweats a lot, which is common in recent amputated patients, they sweat a lot, you will also choose preferably the Protect version instead of the regular stiff version. And also it helps to use a Protect version when the patient has little wounds or scars. That will also help them to have a good, safe contact with the material. At the end of this presentation, I will show you the molding of a PETG, which I prepared right now. As we need some activation time, I took a sheet of 12 millimeter, which brings me also to a time of 12 minutes. And so that you don't have to wait, I will put it right now in the oven to be activated while I will go on in a few seconds with my presentation. I removed the sheets, the protective sheets on my sheet. I clamped it in a frame, and this frame I will put in an infrared oven for this demonstration, and I will need more or less 12 minutes, which is corresponding more or less to the thickness of our material. So I will put it right now in the oven, and then we will go on with the next slide on the presentation. I just turned on my timer so that I will be remembered when my material will be ready. What's important for you as a distributor or end user is to recognize the similarities between the Orfitrans Stiff and the PETG. First of all, we extrude our product so that you have a high quality, means that there is not a lot of stress in our material, so it won't shrink too much, that you get an even thickness and a very nice surface as an end product. We are able to produce that in different thicknesses, and both products comes in the same thicknesses, being 8, 10, 12, and 15 millimeters. We provide them in different sizes, standard sizes, which are 400 by 400, 600 by 600, 1225 by 1225 millimeters. Those are the sizes that you can standard get from us in the different products. Both are designed to be check materials, and you will use them mainly in bubble forming. There is less activity or less use in the orthotic test devices. What you also can do with both products is the activation with a convection or an infrared oven. I'm using an infrared oven because this has the advantage to heat up my material on an even way, so this activation will happen at the same time on the outside as in the middle of our sheets. Both also are designed as material to be easy to adapt just by adding materials by gluing or by sanding or by heating them locally. So that's where we can do it. Other similarities we always bring to the market with a protective foil. Protective foil is needed for transportation to protect the sheet, but also to avoid humidity going inside of our sheet. Humidity is enemy number one of our sheet material. During manufacturing, we really remove all the humidity out of it, and we don't want that to get in during the when you carry it or when you're stocking it. Easy to form. We designed it so that it can really mold and drape quite easily. We made the formulation in that sense that it forms uniformly. Be aware that the materials, stiff and PETG, are non-sticky. So it means that you are not able to stick it together. So it's not intended to have a drape forming application. Same activation temperature, which is 160 C or 320 degrees Fahrenheit. And be aware that both have a very high fatigue resistance. So you can really put your patient on it and give them some activity. What are the main differences between Orfitrans Stiff and the Orfitrans PETG? Well, on one side, of course, is the basic material, where on one side we use the PETG, on the other hand, we have the styrene-based product. The PETG, we advise to have it for shorter. They have a shorter activation time, so it will be heated much easier. It's more or less 1 minute per millimeter, where the activation time of stiff is much longer. PETG is absolutely clear, where the stiff is slightly bluish. The advantage of our PETG is much stronger than all the common PETGs that we have on the market right now. Whereas our stiff is really indestructible. It has been proven for years that it's really a very strong product. And I say that PETG is more rigid compared to Orfitrans Stiff, although both are really rigid enough and they can bear a lot of weight. But if you measure it, it will be a bit more rigid. I would not advise to use PETG when you are cutting out windows in your test socket, where you can do it very safely on the stiff material. You can cut out windows. You can use windows that are closed or left open when you're making your sockets. And we advise to use the PETG when you are testing and testing and controlling the patient. I will advise to do it in a supervised environment, just for safety reason, where with the stick you can easily send them out to the home and you might be absolutely sure it won't break. Also important for your end user is the way that they store the material. We see that sometimes the material is stored in a bad way, so we suggest to keep them in their original packaging. Leave or keep your sheets in an upright or in a total flat position so that there is no angle, because then you get deformity over time, which might affect a bit the quality of the product. We advise to store them in a dark place and avoid UV light. That's also destructing over a long period. It might affect a little bit the product. So if you can, dark and UV protected area. Dry place. I already explained that humidity is our enemy number one. So keep it in a dry place. Leave the protective foil on the sheets so that no humidity can go in. And the temperature that we advise to keep them is between 10 C, 50 F, and 30 degrees Celsius. That's a temperature where you should keep your material in. For the product activation, I already told you that I'm using an infrared oven. A convection oven is also good, but that will take even a bit longer, and it's more difficult, especially with thicker sheets, because the activation time before the heat goes from the outside to the inside might take a bit longer. If you want to make orthotic applications, or I would suggest to use a flat oven, or you can activate your material flat in your infrared oven. Also apply the correct temperature. I see very often in workplaces where the temperature is not correct, although sometimes the oven shows a correct temperature. If you check your oven, you might find some difference. So advise your customers to check regularly the oven temperature, so that you're sure you are really reaching the good temperature when you are using our materials. And also, I would suggest to pay attention to the activation time. Don't make it too short, not too long. In the case of a socket, I will advise to let them draw the material for 2/3 of its length before you apply it. So that's also important to pay attention to. For the fabrication, you can use, as we will show you later on the plaster mold, or you can use a positive foam mold. Both works the same way. I mentioned already 2/3 of the length of your device that you should let drop your bubble before you apply it. And for both material, PETG and for the stick, I will recommend to pull the socket very slowly. I see very often that a lot of people are pulling too fast, and that also end up with a result that the walls are not even in thickness, that you destroy a little bit the molecular structure and make it weaker. So one of the things is, take your time. You have time enough to pull your material, and that's what you do. Little tips when you're using a plaster cast. I make air channels to the distal brim of my socket on different sides. So I have air channels to allow the air suction to go through up to the socket. I will make sure that my cast is absolutely dry, and I will always insulate it. Some people are not doing it, and that means that when you apply a heat, even some damp is coming out of the plaster, going in the material, and that weakens also the end result product. So I will insulate it with a little bit of varnish in my case, and I will also use a little bit of demolding silicone to be able to remove it quite easily. I will also use a very thin stockinette when I have a very complex case of very complex shape that allows the air suction and also the removal. It will make it more easy to do that. On foam molds, you can use a very thin layer of grease also to enable it not sticking to the foam when you're pulling your socket. When you've done that, you have to let your material cool down for a long period. I see sometimes people are removing their socket or the device immediately from the cast. It's really not the good thing. If you remove it too early, you will have a residual stress. But I hear my timer going off. I will just go on with the presentation after that I pull my socket. I will just check how long we are, and then I will discuss the residual stress, what it is and why to prevent it. And I have a few minutes left because my bubble is not formed completely. So let's discuss the residual stress. If you don't allow the material to cool down, the molecules to set, and you start removing it by pulling, by knocking it off, by blowing air to remove it from the cast, you will create stress. This stress can lead to little cracks, and that may end up to a weakened wall. Even cracks can appear, not immediately, but later on, and then you don't know where it's coming from. Well, residual stress is something you really need to avoid. So I would suggest to leave it as long as you can. 24 hours for stiff if you can, a couple of hours for PETG if you can. If you really want to start working on your socket, I would break out my cast instead of knocking it out. That will prevent creating residual stress. Once you release your socket, you can start trimming the edges by sawing into the edges. You can grind it, and you can finally polish it, and you can start building up your device. You can screw your adapters to it, you can stick them to it, and then you finally can start with the evaluation on your patient and adapt your socket. And hopefully, meanwhile, my material will be dropped down enough, and I will, and that's correct, it's dropped down quite a bit. I will take it down, I will put the convex, I will put it on the socket, and I will displace it a little bit, in this case, to the anterior lateral wall, because that's much longer than the medial posterior wall. And as you see, it was convex. I allow it, before I start pulling, to fall down against my socket so that I don't even have to pull. It's the material who is doing the work. I don't have to worry about conforming it by helping it. And then I will start pulling very slowly down up to my rim, where I will create my vacuum. And also the vacuum is something important. Don't turn it off at once. I do it very slowly so that you allow the material to conform perfectly to your cast. And I will do it step by step. And you will see that I'm not pulling it completely out, just step by step, so that I don't even have to help my hand to completely stick to my cast. If you have to help it a little bit, you just can't help it slightly, but if you do it the way I did, you don't need a stockinette, you don't need a help. It's the secret to do it very slowly. I hope this gives you a little bit of instruction that it will help you to provide some instructions to your customers. You can always look it up at and join us at the social media. We also have a lot of instruction movies on our website, which you can consult before you are going to your customers. And I think the time has come to open up the questions. Today we will review the flexible range of Orfitrans. I will share my agenda of today. So we will discuss the Orfitrans product range. As I said before, mainly the flexible range of our products, which are intended to make flexible inner sockets and also have some applications in orthotics. The idea of today is to have a little demonstration on an orthotic application as well as a demonstration on bubble forming Orfitrans Extra Soft, so that you will see again how it works. And if you have questions, you will be able to formulate them. I will try to answer them at the end of the meeting. Meanwhile, you can always put some questions on the chat, and we will collect them and try to answer them also at the end of this presentation. We will go through the whole range of products, starting from the medium soft. We will discuss quickly the Excel, having a demonstration on that. We will also go through the extra soft, which I will make an inner socket out of it, and then we will discuss the Supra soft. We will discuss the product similarities and points of attention when you are using our materials. But let's get started. For the one who attended the previous webinar, I showed this slide already in the way that we are dividing our materials a bit in three parts. The upper part, which we discussed last Tuesday, are our check materials, mainly check socket materials, being PETG stiff with the protect version on it. On your left-hand side are the products that we will mainly discuss today, being the materials or flexible material, which are mainly used for inner sockets, but there are also applications in orthotics, as I will demonstrate later on. On the right-hand side, you have the test orthosis materials. We discussed stiff and PETG, but today we will also point out our Excel, which can be used for the orthosis, definitive orthosis. Important to know that our catalog, our setup is also made up in the following division. We start with the most flexible, the most rigid flexible, which is the medium soft range, which has a flexible modulus of 75 megapascal. And then we go down, and that's the way we align our products. That's also a way to choose your product. If you want something rigid, you will choose the top ones. If you want something very flexible, go for the Supra soft, which has a very low flexible modulus. So that's the way we will divide them and arrange them. We listed them. So we have first the medium soft range, second one the Excel, extra soft as a third one, and the Supra soft being our softest material. What are the applications of those flexible materials? Well, they are mainly intended to make inner sockets, but also for lining and orthosis. Excel has those applications where I will give a demonstration later on, but not only orthotics, also lining can be used with our flexible materials. And depending on the muscle activity, on the patient's activity, depending on your own choice, you can choose between flexible, going to a very flexible, very soft material, Supra soft, as we mentioned already. Recently, and we added a feature in our product, which is the Protect. And Protect is an element that we add, that we mix in the whole product. And we add a product that reduces the activity of bacteria. We try to prevent the growth of bacteria, and I list them here, which is the MRSA, very well known, Staphylococcus, the superbacteria, the VRE are the most common bacteria that we try to reduce of growing in our devices, or sockets, or orthoses. Those give smells, which is really not pleasant for the patient, and it might also affect a little bit our end product. So we have been adding this, and you will see when we go through the products in which products the Protect is available. Let's discuss the range. First of all, the most rigid of our flexibles is the medium soft range. And this comes in 4 types. And we have the medium soft Protect. We have the Orfitrans Medium Soft Beige, and the beige with added Protect element. Be aware that this range is completely based on EVA. It has a very high flexural modulus of 75 megapascal. It's the most rigid, as I said, of our flexible materials. And very important, and we try to do it for all the range, is to provide our materials with no cold flow or a very low, so that it maintains the shape of our products. Let's go in details. We have our range of the medium soft, and we have it in clear and in Protect version. The clear is coming and is a little bit milky, as you can see. Be aware that we also, in our formulation, we add products to prevent yellowing. Sweat, UV light might affect the color, which is not pleasant for the patient. So we reduce the yellowing by adding some products in our material. Main use of this material is the inner sockets. Especially when you have patients with a reduced muscle activity, you want to have something rigid, as the patient is not able to activate his muscles very well. Available in 8, 10, 12, and 15 millimeters. We have the same, and it looks the same. We have the same in the Protect version. The only difference is that we have been adding this antibacterial product inside our material. Working features, the features are exactly the same, and the available thicknesses also are identical. Let's go to the medium soft beige. Medium soft beige, it's just the color who is changing. This is for aesthetical reasons. Also, the applications and the working methods are identical. The properties of the materials are identical. The only thing with it is we added a thickness like 6 millimeters. And the idea is to also use this kind of sheets in upper limb sockets or orthotics. Again, we extended the range with a Protect. So the beige comes also with the same properties. And also we added 6 millimeters in the Protect version. So that's the whole range of the medium soft. Remember, the most rigid in the flexible range. The next one that we have is based on a different base product, which is PE copolymer, polyethylene copolymer, resulting in a lighter product than the similar products on the market. Big advantage of the basic material is that it's self-bonding. Self-bonding means that you can use it either in the bubble forming, on the other hand, in drape forming. You can make a seam, and by drape forming, you are able to form a device that has a very even thickness through the whole device. You can use it. It's so flexible that you can use it in sockets where you have windows, so that on the opening where the windows are open, you can allow the material to expand. You can allow muscle activity, but we made it so that it has a flexibility and it comes back to its original shape. And we have a very or no cold flow. So it means it will maintain its shape and it will not stretch out during time of wearing. It also has a very silky and smooth surface. And we have those in two versions. On one hand, the Excel Clear, on the other hand, the Excel Black. And I will just give a demonstration on the manufacturing of an orthotic application. It's a very easy thumb wrist spiker that I will make out of an Excel 3 millimeters. And first of all, I will put it in the oven and I will give you more explanation on it. Remember that it comes with a protective foil that you have to remove before you put it in the oven. I will put it in an infrared oven and I will just place it flat in the oven on the base of the oven and let it activate for a few minutes. Allow me a few seconds to put that in the oven. I will allow it for activation during more or less 3 minutes. As it's not bubble forming, you can play a little bit with the time, but not too long. Please respect the activation temperature and time. What is important, and I think the market is not aware that we have it in thin thicknesses like 3, 4, 5, 8, 10, 12, and 15 millimeters. But I point out that the thin materials, which are useful to make orthosis, also to make lining, you can use it for inner shoes, you can use it as a protective device in other orthotics and prosthetics. And that's something that the market is not really aware of. I will just demonstrate this. That's the end result. I will point it out later on. The idea is to use the stickiness of the material. I will make the seam. And just to let you know, see, I didn't use a stockinette, but I made an air channel on the place where I intend to have my closure of my splint. So that's the way I will remove the air. I connect it to a vacuum system, but in fact, it's the material itself that will do the job. I will just seam it around the place where I'm going to close it, and I will be able to open it again. Talking about the seams, you can, when you make your seam, I sanded it down, and you can finish it by polishing it. Another way is to reheat locally your seam. You just sand it a little bit down, you reheat, and then you use a round piece to roll your seam down so that you have a very even and flat seam so that it's not disturbing. When you use a vacuum, and that's going to be very difficult, you will have no bridge inside. It will be completely flat and connecting to your mold that you initially made. So that allows a very soft and flat inside, and also the outside. By rolling or sanding it down, you can have a nice even surface. As I said, you will have an even thickness all over your device. You can also make that for inner sockets if you want to have an even thickness, which with bubble forming is not always the case. It's always thicker at the distal side than on the proximal side. And I remembered by my timer that my material is activated. Time to take it out and to apply it. I will take it out carefully and I will place it on my cast, being careful that it doesn't stick where you don't want to have it sticking. I will close my oven. And then I start just closing the whole material. I will make my line on my air channel. Once it's completely closed, I stretch it also slightly upwards. I will turn on my vacuum just to have full contact with my cast. Don't need a lot of vacuum. A very light one will be enough. I have a little air entrance somewhere, which I'm not worried about. It lies completely around the material. If you want, you can trim it right away. I need the scissors for that. You can trim it when it's warm. It makes it easier to trim it right away. And then you allow it to cool down on your cast. It shouldn't stay as long as you do for the rigid materials, but the longer you leave it, the better and the stronger it will be. So that's the way where you can use it and you will see the result of the product. You're just gonna cut it away and you just finish it by grinding, sanding, and that will be the result that you will have. You have a bit flexible orthotic device. You can make a lot out of different shapes, as I said, inner sockets, lining, and so on. So that's an application which is not very common or not very well known in the market. That's the reason why I show you this. When we go on, we will have also the Orfitrans Excel Black. And the Excel Black, we don't have thin sheets for the moment. So the product is exactly the same. It's only the color who is made the differentiation. It's also flexible. It has the same properties as the clear, only the color. And we don't have it in thin versions. So your versions that you can have are 8, 10, 12, and 15 millimeters. I will just take a few seconds to remove the setup here to prepare for molding. So allow me a few seconds that I will dismantle this and prepare for bubble forming our socket later on. As we will discuss the extra stuff, and we will give a demonstration, I need to raise the temperature to 150 instead of 130, which I use for the Excel. So the next in the range, which has a little more flexibility, is our Extra Soft. And the Extra Soft comes also in two versions, in the clear version and in the beige one. Both are EVA based. They are very flexible. They have a lower flexible modulus than the previous one. Very stable product, no cold flow, and they give very high comfort to the patient. The only thing is that we provide them in different thicknesses, like for the Extra Soft Clear, if you call it like that, it's 9 and 12 millimeters, mainly used for active patients and inner sockets for active patients. Where the beige one, you also can use that for the same purpose, but also for upper limb, and that's the reason why we added 5 millimeter thickness in this color. So that's the only difference that we have. What I'm going to do while is put a sheet in it, which will be activated during when I'm continuing the presentation. I already removed the protective parts from my sheet. I put it in a clamp and I will put it in the infrared oven, and I will need more or less 9 minutes to be activated. So I will do that while we are going on with the presentation. So I turned on the temperature, I checked the timing, so that's going on. The Extra Soft, we have two versions, clear and beige, but also we have another version, also EVA based, which is also very flexible, has the same flexible modulus as the previous one. Only the color differentiates, and the color differentiation comes from the silicone that we added in the product. So we call it Extra Soft Silicone, and the advantage of the silicone is that it has a very slicky surface. So the problem for the patients is always to don and doffing their sockets. So this product enables them to have a very easy donning and doffing, as the surface is very smooth. Might even feel a bit greasy, so that really enables the patients to glide in and out of their socket. Has the most smooth surface in our range, very flexible, and has no cold flow. If you see to the competition, there is always an issue. We reduce the cold flow to a minimal, which is a big quality advantage of our product. And we had it in 9 and 12 millimeters, and recently we added the 15 millimeters. Was the demand for the market, so you can tell your customers that we can provide it in 15 millimeters from now onwards. So that's the Orfit Extra Soft Silicone. And if we go on with our range, we have the Supra Soft. And the Supra Soft also is really made on the demand of the market. Very active patients, techniques are improving, so the flexibility of the sockets were demanding to be more and more flexible. So we made a very flexible 20 megapascal. It's really flexible and soft. Has also a very smooth and slicky inside. It has a bit of a milky aspect, and has a very low cold flow. And also because of the applications, we provide it in 8, 10, 12, and also 15 millimeters. It has a very a big range of applications, especially with very active patients. So that's the softest or the most flexible at this time in our range. what are the most common properties of flexible range? Well, they are mostly intended for inner sockets and orthotics. Most of them are EVA-based, except the Excel. They are non-sticky, except the Excel. You can bubble form them all, and you can also drape form the Excel. So the Excel, as you see, has a bit of more properties than the other ones. We designed the formulation so that it has a good drape, and I will show you that the drape comes from the material. You don't have to really pull or push yourself. They're all easy to finish. You can grind, sand them, polish them very easily. And we tried also to reduce the cold flow in all our range, because that's a big issue. If your patient is wearing this prosthesis for a long time and it stretches out, you're losing the shape and you're losing the comfort of the patient. Important that you remind that we sell them with a protective foil on both sides. The reason is, first of all, to protect our material when we are transporting them, but also to prevent humidity. And humidity is something that we don't want to see going on our products. Be aware that our products are humidity sensitive, so the more humid, the more issues you can have. Try to keep them in a very dry place. Leave the packaging on, leave the foil on till the last minute when you use it. About storage, I would say we would advise to store them in a place that has a temperature between 10 and 30 degrees C. It's important that you store them or completely vertically or completely flat. If you incline them, they might have a little deformation, and that will also affect the qualities of our product. Also, try to protect them from UV and daylight. Keep them in a box or in a dark storage place. Also, other points of attention: always check your sheet before you use it. Remove the protective foils. Label is very important. Remind your customers that they have to keep track of the label. By keeping the label, by taking a picture, that's the only way where we can, if necessary, trace where something went wrong, if something goes wrong. That's the only way for us to track our production from the beginning to it comes to you and the end user. You can activate the materials, all the materials, in a convection, an infrared, or a flat oven in between, an oven with two sides activated, especially when you're making orthosis. Also, respect the advised temperature. Don't try to heat it above the recommended temperature or below. It wouldn't work, and it would only affect the material. Activation temperature is for all the flexible materials in the range is 150. One exception, of course, we have the Excel, which is 130. Concerning the molding, you have the material to let do the work. So don't pull or don't leave the material to drop down too quickly. Take your time, do it slowly. It will give you a better result. Also, the material, once you want the material to have be dispersed on an even way, take in account that you have always places with longer sides versus shorter sides. In this case, it's the lateral and anterior side that are much longer than the medial and posterior wall. So I will displace my bubble when I'm going to pull it on a lateral anterior way. I always advise to use a dry and especially insulated model. As the material is activated, the molecules are open, and when you apply it to a cast that's not insulated, the damp might come in the material, and that might slightly affect the material. when you are molding, just turn the vacuum very slowly on. But I think it's time to go over to the molding. I will check if my bubble has formed 2/3. It's nearly there. I give it another minute to drop down. Also, the next points you have to pay attention is to let cool down your material completely before you remove it. And you have to remove it carefully. Don't try to knock it out. Do it very slowly. And if you are making an insert socket, you can leave it on and make your outer socket later on, or you can remove it and replace it by stockinets to have the exact thicknesses to make your definitive socket. Finishing is just the same way as we do for the rigid products: grinding, sanding, and polishing. Another big enemy of our products are the solvents. Never use solvents because those affect seriously the product and it might cause issues later on. A little word about the Excel. It's self-adhesive. You saw it during the demonstration. The main application of that is that you can drape mold for orthotics, also for sockets or inner sockets. And that's the only differentiation that we have is the temperature. Otherwise, it's always 150. By the way, I will go back to my bubble. And we are there. We are 2/3 down. As you can see, I made air channels in the material. So I will be able to activate my vacuum later on. I will pull it upside down and then I will position it. And as I said before, I will do it a bit lateral anterior. And the big difference with the rigid materials, I have to hold it back instead of pulling it down and let the material fall down against my cast so that the air is put away. I don't really need a lot of suction, and I'm going very slowly down. And that allows the material to slip a bit down. That gives you an even thickness and also remove the air between the cast and our sheet material. And with the flexible materials, it's also even more important to activate your vacuum very slowly so that you don't have any wrinkles forming. I do it step by step. If you do it slowly, you probably don't have to help the material to form. You can slightly help if necessary, but if you do it this way, you do it on your own, and the material is really doing the job for you. So you have to leave it for a while on the cast while it's cooling down. So that's the way you can do for all our flexible materials. Do it slowly, hold it back, but pulling it down with the rich material. So we will let that cool